What's up, everybody? Welcome to Danger Person Code. In this video, we're going to tackle the two-sum problem. This is the infamous two-sum problem that you have probably encountered at some point on Leet Code. If you haven't already, you probably will at some point in the future. So basically what this problem asks us to do is it gives us an array, and it also gives us some target value represented by k. And then it asks us, do two numbers exist in that array that sum to k? Are there two numbers in this list of integers that when added together equal k? And then it asks us, can we not only detect whether or not those two numbers exist, but can we return the index locations of those two numbers? Okay, so that is basically the algorithm that we're about to write. There are a couple different ways to do this. As usual, there is a brute force way of doing this, and this may have occurred to you already. It doesn't give you a very good time complexity. It will be exponential or n squared, right? We could just simply have embedded loops where we iterate through every element in this list, and for each element, we iterate through again and add each element to the element that we were originally on, and just see if it adds up to k, right? That'll give you the answer, but you also might time out if the list is extremely large. And even if it doesn't, it's extremely inefficient, right? So if you're training for interviews, you want to do this in a much more efficient way. And we are going to do that with a hash table, right? Which is essentially a Python dictionary, okay? Dictionaries are based around a data structure called hash tables. So what we're going to do is we're going to use a hash table to record every value and its index that we have already visited in the list as we move through. And we are going to cross-reference everything that we have stored in that record with the value that we are currently on, right? And in this way, we can iterate through the list only once, and we will get a time complexity of O of n, okay? So without getting into a whole thing about exactly how this works, I think I would rather just show you. And so let's start coding. So the first thing we're going to do is we're going to create a dictionary called visited. And this is going to be our record of everything that we have already visited. And if you're unfamiliar with dictionaries, Python dictionaries, they store data in key value pairs. The key for visited in this case will be the value, right, that we have visited, and the value, right, in the key value pair will be the index of that value. And the way that we're going to go about tracking value and index, right, as we move through the list and then storing it in visited will be with the Python enumerate function. So I haven't used this before. Let me show you what enumerate does and how it looks in a for loop. So I'm going to write a for loop right here. So I'm going to say for index, value in enumerate R. And before I get into what happens for each iteration of this list or this loop, enumerate allows us to make an additional temporary value or variable that stores not only the value, right, that we happen to be on for a given iteration, it will also store the index of that value, right? So it allows us to track the index of each element that we happen to be on for a given iteration of the loop. And you'll see why this is going to be really helpful. It's not necessary, right? We could do this with Python's more basic syntax, and other languages like, as far as I know, JavaScript or some of the more low-level ones like C++, they don't have anything like this, right? So you'd have to sort of make do with that more basic syntax. You could also do that with Python. But because we have it, we're going to use it, and it is really helpful. So as we go, right, the first thing that I'm going to do for each iteration is I'm going to define a value called sumCheck, okay? And sumCheck is going to equal k minus the value that we happen to be on right now, okay? So the value that we're on right now, right, when subtracted from k, right, will equal sumCheck. And what then we're going to do is we're going to check whether or not some check is in visited, whether or not it is in this record that we are keeping going as we iterate through the list. And if it is, what that basically means is we've found we are currently on a value, right? That when added to some other value that we know we have visited at some point in the past, right? Those two things would equal k. It would essentially mean that we have found two numbers that add up to k. Okay, so we are going to redefine sum check every time we have a new iteration of right, and then what we're going to do is we're going to say if sum check is in visited, right, thereby signifying that there is something in visited that when added to the value we're on right now would equal k. Yeah. If that is the case, then we're going to return visited, sum check, right, and index. Okay. So these are going to be the two indices of the values that we know now to add up to k, right? Remember, right? K minus value is basically just what we're saying here is this is just a stand-in. This is another way of saying some number that when added to value would equal k, right? K minus value equals something that when added to value would equal k, if that makes sense. So if this is here, what that means is we've visited at some point in the past some number that when added to value would equal k, which means not only do those two numbers exist, but we now have both of their indexes available to us to return. The first index that we have, the easiest one, right, to access is the one that we're just on right now, right? Enumerate allows us to track that. The other index, right, is the one that we stored. Remember, like I said, we store in key value pairs in the dictionary, right, the value, right, as the key and the index as its value, right? I keep using the word value interchangeably, but that's how things are stored in dictionaries as key value pairs. Okay, so you could also even just write some little F string here to kind of just drive the point home. You could say, oops, sorry, say the two values that sum to k are located at index visited sum check and index. Okay. Now, if for a given iteration this is not the case, we don't find sum check in visited. Okay. In other words, else. If this is not what's happening, if we're not finding sum check in visited for a given iteration, what we then need to do is iterate ourselves forward, right, into the next iteration of the loop, the next element in the list. But first, we need to store the value that we're on and its associated index in visited. We need to store it in the record so that we can go back to it, right, in subsequent iterations. Right? We need to keep growing that record until we get to the end of the array. So we're going to then create a key value pair that doesn't currently exist if this is the case. So visited value will equal index. And this is this, right? And this, right, is this. And we're just creating now a key value pair in visited that we can go back to and check on as we move forward in subsequent iterations and are evaluating subsequent elements in the array. Okay. Now, as we go, if we get to the end of the array and we do not ever have this come true, right? Sum check is never invisited. We don't find it. What that implies is that there are no two numbers in the list that add up to k, right? They don't exist. And so we just need to print something that would indicate that, right? No two numbers in the list sum to k. And then we can return false, or some people will return -1. I prefer to return false. Okay. And that's basically it. That is two sum. You're looking at two sum right now. And this will, again, solve the problem in an O of n worst case time complexity, because we're only iterating through this list once, right? And yes, it does have to check an entire dictionary every single time. You could also do this with a list. If you did this with a list, with a Python list, it would again produce an n squared exponential time complexity, because it would have to go through that entire list every single iteration. It would be no different than having two embedded loops, right? However, interestingly, checking a hash table or a Python dictionary is done in constant time. So there's no additional complexity added to the big O of this algorithm by using a hashtag. There would be if you used a list, but not for a hash table, not for a hash table. So let's test this out, okay? So I have my array of numbers here, and I'm going to call toSum on nums, my array of numbers right there, and I'm going to assign k a value of 50. So we can see in this array that two numbers actually do add up to 50. We have 35 and 15. 35 is at index 2, 0, 1, 2. And if you count all the way over here to the right, 15 is actually at an index of 10. So not only should it detect that these two numbers exist, but it should return an index of 2 and 10. Okay, so let's run this and see what happens. And first, let me expand the terminal a little bit so you can see the output. And the two values that sum to 50 are located in index 2 and index 10. Great. Okay. Now let's say I changed k to 500, right? Now we can see there are no two numbers in this array that add to 500, so it should give us this message: no two numbers in the list sum to k. And that's exactly what it does, right? It just moves on to the next part of the code, because this never ends up becoming true. We get all the way to the end of the list. This code never gets executed, and we just move on to the next, where we print this and return false. Okay, so that's basically toSum. Let me just expand that out there in all its O of n glory. So if you have any questions, throw them up in the comments. Feel free to like and subscribe if you like this video, and join me in the future for more brutal, savage algorithms. All right. See you next time.